Hi everyone, my name is Argenis Fernandez. I am a principal architect with Pure Storage, and I'm here to talk to you guys about advanced storage troubleshooting for SQL Server. I call this session the layers of the cake, and that's for a very specific reason. Troubleshooting storage doesn't mean troubleshooting any one thing. You're typically troubleshooting more than just the storage device itself, because really serving I/O is a function of the application, the operating system on which the application runs, a VM, potentially if you're running a hypervisor, the hypervisor itself, potentially storage network, and then finally the storage device itself. So it's complicated. There are a lot of moving pieces when it comes to troubleshooting storage. So I'm going to try to make it informational and educational for you guys, so hopefully you'll enjoy this session today. About me, again, I'm Argenis Fernandez, Principal Architect at Pure Storage. I am a Microsoft Data Platform MVP. I'm also a Microsoft Certified Master. If you hadn't heard about that certification, it was one of the best certifications that Microsoft ever had, and then they decided to cancel it. I'm also a VMware expert. I've been for several years. And I used to work in the SQL Server engineering team as a PM. I was in charge of several things, including SQL PAL, which is the layer of software that enables SQL Server to run on Linux and Linux-based containers. And I was also a PM for the persistent memory support for the database engine. So I was going to do a storage 101 session. I really wanted to talk about, the basics of storage so that people would understand, at the very basic level, how storage systems work and how SQL Server interacts with those systems. And then this guy right here sent me a note and said, I like your session, but really, man, we just want you to melt our brains. So I said, well, okay. I mean, if that's what you want, that's what you'll get. So here we go. This is a level 500 session. If you're not comfortable with storage concepts, this is definitely not the presentation for you. So at the very least, you should go back and watch this presentation that I'm linking to here. Obviously, the link is available on the deck for the presentation. That is a presentation that I did for Group Buy. It is freely available online. You can go watch it in YouTube anytime. And it talks about, all the different layers. It talks about the basics of storage, latency, IOPS, and throughput, and all those little things that are super important to discuss when it comes to storage. So if you don't know anything about storage and SQL Server, you definitely want to watch that one first before you come back to this presentation, because we're going to go in depth in here. We're not going to have time to explain many of the details of things, because this is only a 60-minute plus 15-minute Q&A presentation. Anyway, getting back on track, I do want to make sure that I highlight one thing, and it's the fact that this presentation can induce curiosity in you guys. And what I mean by that is you can break your storage subsystems and your production environments if you attempt to use some of the things that I'm going to show you in this session on your systems. So you have to be extremely careful of things. So don't just do whatever you want and go try things on, because you may break your systems. So don't blame us. Don't blame DPS, don't blame me if you do break your system. So be careful. Understand what you're doing. Test on a test system. Don't test in production. That's typically a very good idea. Anyway, the agenda for today. We're going to go over troubleshooting SQL Server at the very highest level possible, which is SQL Server itself. Storage. We're troubleshooting storage, remember? So we're going to troubleshoot storage at that SQL Server level. Then we're going to troubleshoot at the operating system level. Then we're going to go down that layer of the cake again, and a layer of the cake again, and we're going to troubleshoot at the hypervisor level, and then we're going to troubleshoot at the storage network level, and then finally we're going to troubleshoot at the storage device level. So you see, we're going to go over all the different layers of the cake here. So there's a ton of information to go through, so we have to get going. Now this right here, this is a slide that I also used in that presentation that I referred to earlier from Group Buy. I don't expect you guys to actually understand all the little things going on in here. I don't expect you to squint and pay attention to every single box in here. I just want to highlight one thing. This is the storage stack from Windows as it was a few years ago. And it's changed since. So it's potentially a little bit more complex these days than it already is, as you can see in your screen. The thing to highlight here is that storage systems, even within the operating system itself, the stack is complex. There's a lot of things going on, and there are places where there are different observers can be placed at various layers of that particular stack, and so that's actually how antiviruses and anti-malware works, right? They insert themselves on one of these layers and they crack open IOs, and they examine the IOs as they're being issued against a subsystem. So that's how they determine whether an IO is a good IO or a bad IO. I also call them free latency, right? Because that operation itself takes a long time. Even the operation of just having a file that's discarded, meaning it's excluded from the anti-malware itself. Even if you have a filter that has to see whether it actually cares about an IO given against that file or not, that operation on its own can take some time. So I have seen horror stories coming from anti-malware on being used on SQL Server, but that's not the topic for this presentation. I just wanted to highlight the fact that storage stacks can be complex, super complex. All right, so digging right into it. We're going to start with troubleshooting at the SQL Server level. And so remember all the layers of the stack, right? We have the application at the very top, we have our operating system, we have our hypervisor, we have our storage network, and then we have a storage device. We're starting at the very top of it. And so in the SQL Server layer, we have to consider a bunch of things when it comes to SQL, right? What are all the different things, or the different indicators that SQL Server has for a potential storage problem? Right? How can we diagnose whether there is a problem with the storage subsystem in SQL Server? So there's a few that are like classical, right? Number one is absolutely classical, or the traditional way of diagnosing a performance problem that's related to storage in SQL Server is IO-related waits. Okay, so as you guys know, waits are kept at both on a per task level, in the shape of a DMV called OS waiting tasks, and the other one is at the instance levels, right? So there's a DMV that tells you exactly which tasks are being, which weights are being collected, or how weights are being leveraged in your system at an instance level. And so if you query your DMV's system at the instance level to tell you what the weights are, and you notice that at the very top of the weights, when you order them by number of weights, etc., you start noticing that IO-related weights are at the very top, like write log or page IO latch or backup IO or maybe backup buffer. Those are clear indications that your system is actually under pressure from the IO subsystem side. And so you need to actually start troubleshooting your storage subsystem and figure out exactly what's going on. Clearly, you can also query waiting tasks. At any given time, your system is performing some work. You can tell exactly, out of those tasks, what are those tasks waiting on? And if the weights that are those tasks are sitting on are related to storage, again, I mentioned a few of those weights earlier. You have a lot of tasks waiting for IO-related weights. There's something wrong with the storage subsystem, right? Your storage subsystem is just not responding as fast as it should. And so that's another classical way of looking at things on SQL Server level. This is also very common to see on systems where you have performance issues related to storage. On the error log, you will see a lot of entries that read something like this. SQL Server has encountered a given number, maybe 100, maybe 1,000, occurrences of IO requests taking longer than 15 seconds, with additional information on the files or on which those IOs have been taking longer than 15 seconds. It's important to highlight something here. The fact that SQL Server is telling you that an IO took more than 15 seconds to complete for a given file doesn't mean that you didn't have any IOs that took 13 seconds or 12 seconds or 10 seconds. You had a lot of those, and eventually you started reaching the threshold that which SQL Server decided to start issuing those messages on the error log because your IO is so slow. And so this is a dead giveaway that there's something going on with your storage subsystem, and you should definitely take a look at it. And so furthermore, you can query sys.dm.io virtual file stats and notice the IO stalls for your data and your log files. And so if you have a lot of IO stalls and your response times are elevated, as indicated by virtual file stats, then you definitely have some issue with your storage subsystem. You can also set up an extended events session to track IO and notice that the time that the IOs take to complete is high. If it is high, obviously you have a performance problem with your storage subsystem, but you have to be careful with this, because if you do create an extended event session to track IO, every IO, that is definitely going to degrade the performance of all of your systems. So this is more of an experiment that I'm going to show you guys how to track IO individually. In the case that I'm going to show you is actually transaction log IO. But what I want you guys to be mindful of is the fact that you can actually break your storage, your system. You can break your production system and bring down production, or even your test systems. You can inflict severe pain just by creating an extended event session that does this. There are other ways that you can get creative about how do you handle the extended event session, or whether you're going to record every single entry or just discard them, or maybe you want to create a histogram, blah blah blah. Not going to get into that discussion. The point is that you have to be careful what you do here, because an extended event session, especially the one that I'm going to show you that actually uses events out in the debug channel, that can cause issues in your system. Anyway, so we're going to look at two things here. We're going to look at WinDBG to trace IO, and we'll also look at an extended event session. So, first things first, we're going to go ahead and we're going to look at my SQL Server instances. So this is actually running on my desktop here, and so I have a database here called TinyDB, and I have a table called dbo.small. And so this table doesn't have anything fancy, right? It's just an identity field and a filler column, nothing fancy. So I just want to insert default values into this particular table called dbo.small. The way that I'm going to trace the IO generated by this, this is where I'm going to spend a little bit of time reminding you guys of how SQL Server IO works. We are going to insert, some default values, right? To insert these values into the table, we need to follow the write-ahead login protocol, and that means that we actually have to first insert records into the transaction log first before we do anything else. Flush those records all the way down to the storage subsystem. There cannot be any caching layer, any volatile area of storage holding my IOs in between my SQL Server and my storage device. Once I flush those records, then I can continue on with processing. But every single transaction log write that you issue from SQL Server has to be persisted all the way through. And so even if I'm inserting something tiny, like a tiny record into this very small table, this is going to cause a transaction log flush, or a series of transaction log flushes, depending on how many records get generated. And so the way to look at this from an internals point of view, and with this, we will definitely get the 500 check mark, 500 level check mark in this presentation, is that we're going to use the debugger to track the IO all the way through. And so this is how we're going to do it. I'm actually going to use WinDBG in preview, which is it's a Windows store-based app. Right? It's not the traditional WinDBG. I actually like it better over the regular or traditional WinDBG. I think this is the future. It's a lot more graphical. It has things that you can click, and I like clicking on things. So anyway, bear with me. I'm gonna start debugging I'm going to attach to a process. You can see, I have several processes that I had attached to before, but I don't know if these processes still exist. So I'm just going to go ahead and click here, say attach to process. And I'm actually going to show processes from all users. I'm going to sort, and then I'm going to hit the S key, and then I scroll down to where SQL Server.exe is. Okay, here's the PID for SQL Server. I don't care much more about any of that, about the rest of the things here. I just want to say attach. Okay, so once I attach to SQL Server, obviously I have to acknowledge the fact that I need administrator privileges to perform this operation. WinDBG returns control after attaching to the process. And so a couple of things I'm going to do here. Number one thing is make sure that my symbols are loaded. So I run an VM SQL Server. And so if I go up here, I can see that my PDB symbols are PDBs are loaded here. Okay, you can get super creative with this stuff. You can actually browse all the global symbols, right? You get a nice index here, and you can do all sorts of interesting stuff. Like you click here, you can see, a lot of the different functions that are available here as part of the public symbols. I am using public symbols, of course, and so there's just a ton of different things that you can do here. So I just wanted to show you that super quick, and then we're going to go ahead and set up a breakpoint. So our first breakpoint that we're going to set up is at the SQL Server Log Manager's log flush function. Okay, so remember what we were just discussing, right? We were inserting some records into a table. That insert of those records are going to generate some transaction log records, and those transaction log records have to be flushed all the way down to storage. And so this function is definitely going to be called. So we set up a breakpoint there, okay, SQL Server, and then we tell SQL Server just go ahead and continue processing. Now the debug is running, but I have to actually trip the breakpoint. And the way to kind of hit that breakpoint is by issuing now the command that will actually perform the insert, right? Because that's actually going to generate the records. So once I do that, when I hit Alt X here, my WinDBG started lighting up here. So I have hit my breakpoint on log flush. So now I'm getting into the gist of it. I can actually look at my threads call stack, and I can see what's going on. So let's take a look really quick here. If we start kind of figuring out what's happening here, well, there is some processing of some statements that's taking place, right? There's a transaction that is being created from it, okay? And there's also a recovery unit, a subsequent log records being created and flushed from that, from the commit of that transaction. Okay, so you can see kind of how the engine works, right? You takes a statement, creates a transaction, and then it decides to flush the transaction log records for that transaction. So now, we're now within that call stack. But we want to see what happens when we actually flush. And so I'm actually going to create another breakpoint in the Win32 write file API. So this is just the method or the function within Windows that's going to be called by SQL Server using Windows's libraries to perform the actual write file to the transaction log file. So if I do create that breakpoint, right, and then I say G again, I'm going to hit that breakpoint immediately, right? Because my previous breakpoint was at log flush, which is the function that's about to start calling the operating system. Eventually, it's going to call the operating system and say, "Hey, I do want to issue that write against the storage device." So now I said go, and when I said go, we immediately hit that other breakpoint set on write file. So now, if we look at the stack is a little bit different, right? Because now we are we're even on a different thread, I believe. And then at this point, you can see that now we've moved on to something else, right? Some thread got scheduled by the oops, sorry about that. So by the scheduling manager, some thread got scheduled, and what happened is, realized that there was some I/O that needed to be processed, And let's say, okay, well, that IO is part of log writer here. And so all of this stuff is about flushing the log cache. Okay, and then the asynchronous write was issued. And then finally the call to write file. Okay, so now remember how SQL Server IO works. It doesn't actually perform synchronous IO, meaning if you have a task that's going to issue an IO, it's not going to just sit and wait for that IO to complete. Right? If you think about the orders of magnitude of how long things take to complete, your CPU and your memory go way faster than your storage device. So it would be silly for tasks just sitting there waiting for an IO to complete. It makes no sense whatsoever, right? So what SQL Server does is that it tries to perform asynchronous I/O for every single I/O that it does, including transaction log writes. So it's not like, even though it has to flush a transaction log all the way through immediately in order to continue processing, that I/O is going to take time. So SQL Server just says, you know what, I'm going to place that I/O in an asynchronous manner, and I'm going to go eventually going to some other thread is going to pick up the completion for that I/O, and it's going to tell that initial task, hey, that I/O is now ready to go. You can continue processing. So that's at the high level how SQL Server works. And so one of the interesting things is here, since we're calling write file, if you look at the registers, one of these registers actually has a pointer to, or has the address for, the buffer of memory that contains my transaction log record that's going to be flushed to the storage device. Because remember what happens when you issue a write against a storage device, right? You take a buffer that's sitting in memory that's got some information, and you tell the storage subsystem, I want to take this buffer and I want to write it in this particular volume at this particular offset, right? So the storage subsystem translates a bunch of abstract concepts like files and into something more tangible that the storage subsystem speaks. The storage subsystem knows about LUNs. In the case of SCSI subsystems, typically we're talking about SCSI LUNs, and we're talking about offsets within that LUN. And so that's kind of how it works, right? That buffer of memory gets flushed, gets issued against that storage device, and then eventually the storage device comes back and says, yep, I completed that I/O that you requested for that particular write. So that's kind of how it goes. We're going to go ahead and detach here. And I also wanted to show you another way of looking at SQL Server I/O using extended events. So bear with me 1 second while I connect to this VM. That's actually going to allow us to create an extended events session. So bear with me 1 second. All right, so I have my VM online now. Let's see. Here I have my SQL Server instance, and I have a database called TinyDB, just like the one I had on my desktop. And then in here I created a table called dbo.small, just like the one I created on my desktop. And then again, that table is nothing fancy, just an identity field and some filler data there. And so what we want to do is see what happens when I issue again another insert into dbo.small default values. And so the way that we're going to do it is looking at an extended event session, right? So again, let's make it perfectly clear. This extended event session will cause trouble, will cause performance issues, right? Because we're tracking every single transaction log write. Right? So imagine the impact that this can have in a very busy system, right? For every log I/O, there's going to be some record written to this particular ring buffer that we're using for this event session, for the extended event session. And so notice here that we're adding several events, file written, file write complete, file written, log flush complete, log flush start, log single record, etc., etc. And so if I've already created this extended event session, so I'm just going to go ahead and start it. Okay, and then I'm going to go ahead and just notice also the database ID is 6 here, and that matches the database ID that I had in my extended event session. So also, I'm ready to go here. I'm just going to go ahead and kick that off. That insert is going to create some records on transaction log, and that's going to be shown on my extended events session. So if I watch live data, I should be able to gather some some data from my live data here from my extended administration. So I'm just going to wait here for it to flush. It should just take a second. And of particular interest here, we have the file write completed event. And so we have here the database ID equals 6, right? This is what we were looking at. The duration is actually measured in nanoseconds, if I'm not mistaken. So this is actually rounded down to 0. So if you look at the extended events XML, the output in XML form, you will definitely see the actual value of this. Just the live data is rounding these down. You can see the file handle. The operating system does not keep a full track of a file name or anything like that. It knows about a file handle. Once it opens that file, it just issues writes against that file handle. It's a much more efficient operation. That's just how operating systems work. And the file ID is 2, which is my transaction log. File group ID is 0. The mode is scatter gather. Okay, so you don't need to know all the details of this, but SQL Server actually uses many different mechanisms for issuing I/O, and scatter gather is just one of them. Okay, so you can see the offset here within the transaction log itself, and that's actually and that's actually in bytes. So this is how many bytes into the transaction log we're writing to. And this also very important is the size. So this is the I/O request size or the I/O block size. And this is fundamental to understand in storage subsystems because not every single I/O is of the same size, right? If you go back to the presentation that I talked about at the beginning, I do talk a lot about I/O request sizes and how SQL Server I/Os can actually be wildly different across the different operations and the spectrum of things that SQL Server does. In the case of transaction log writes, if the storage subsystem uses 512 byte sectors, it will issue a write for a very small transaction log write that fits within a single sector. It will just flush a single sector. But if you have a lot of things that need to be flushed at the same time, rather than doing those round trips against the storage subsystem and incur into the latency penalty from every single I/O, SQL Server will bundle those writes into a single transaction log flush. And that can be up to 60 kilobytes worth of transaction log writes. And so that's actually an optimization that you can do on your systems if you have a very transactional system. Rather than issuing small I/Os, you may want to issue larger I/Os and keep the throughput of the system faster, better. Okay, you do that by not necessarily flushing every little thing. Maybe you want to do a little transaction where you create, do a begin, do some work, and then finally do a commit afterwards. That helps. That can help with performance significantly. It's a good optimization to know about. All right, so we're going to move on with the presentation right now. We are going to talk about troubleshooting things at the operating system level, okay? And so it's important to understand here that the operating system itself offers a million different tools to look at performance on the storage side. So we have looked at several ways of looking at performance issues on the storage side from the SQL Server point of view, right? And I even ventured into, cracking open WinDBG, in which one could argue you're looking at both SQL Server and the operating system at once. But here we're going to focus more on what the intrinsic tools are for the operating system itself to monitor performance on a storage subsystem. And so the classical one is perfmon, right? Everyone should know how to use perfmon in your systems today. And so what you got to watch out for is your counters for latency are high. So you want your latency to stay as low as possible at every time. You want your IOPS. Let's make sure that we understand, right? IOPS are how many IOs are happening per second, or the amount of transfers per second, right? That's the name of the counter in perfmon. If the number of transfers per second is low, that is potentially an indication of a problem, right? However, remember also that the IOPS carry along with the number an average block size. Right? If you're doing backups, for example, you're going to be issuing very large IOs because you're reading 1 megabyte at a time. So you're issuing less IOs of a larger size. If you're doing a transactional workload and you're writing a lot to the transaction log, well, guess what? It's going to be happening. You're going to be doing a lot of IOPS of a smaller size. And so that's kind of how it goes for SQL Server in general, right? And so throughput is basically the number of IOPS and time with the aggregate of all the IOs that are taking place at a given second, right? Because that's a typical measure. And throughput these days on storage subsystem should be measured in gigabytes per second. If you have a storage subsystem that can only do megabytes per second, you're probably doing your database server a disservice. Okay, your gigabytes per second is typically what you want to aim for. Now, they might not always be available depending on the infrastructure that you use, but definitely on newer or modern storage subsystems, you're looking at throughput in the gigabytes per second range, and the latency can be as low as in the nanoseconds range. If you're talking about persistent memory, for example, your latency against a persistent memory device could potentially be in the nanoseconds range or the very single-digit microseconds range. So it can be extremely low. Resource Monitor is another tool that you can use within Windows to actually troubleshoot storage, right? Because you can actually light it up and then go to the storage side or the disk counters, and you can see the SQL Server files and how much I/O they're actually performing at any given time. And so naturally, the same counters you will see there, you will see latency and you will see throughput. You won't necessarily see IOPS in there, but you will understand whether you have a problem in there. For example, if you're doing a backup and your throughput for that particular data, for your data files is low, your backup subsystem cannot read fast enough from your data files. Right? And in the same vein, SQL Server is going to try to write your backup to a backup device, which may be across the network, etc. If you notice in this using the Resource Monitor that performance against those files is low, but you don't see an issue on your side in the SQL Server, on the SQL Server itself, then there may be an issue with the backup device itself, right? Or maybe an issue with the network just trying to write across to that particular storage device. So that kind of gives you an indication of how things are going within the instance itself. Now, if you really want to get into the gist of things, if you really want to get into low-level troubleshooting of storage for Windows itself, you can do a store port trace. And so store port, I'm actually not going to go full in depth into how a store port works, but you can basically think of it as a piece of ETW infrastructure, so an event tracing for Windows infrastructure, that allows you to look at very low-level operations of the storage level. So you can actually say, I want to measure the latency of every I/O that's issued against this particular volume. And that is great because you can basically discard anything happening at the higher levels of the operating system, including SQL itself, from the equation. And so this is also very interesting because if you notice that latency is high, and in your VM, in your operating system, but everything else below it shows beautiful numbers, then you may potentially be having an issue on your operating system itself. And I have seen this many times with anti-malware or antivirus can actually cause latency before the I/O leaves the operating system, because you're spending so much time cracking open every I/O and figuring out what's going on with that I/O, to determine whether it's a malicious I/O or not. And so that's one of the things that one does to figure out, what's going on with my system, and take a close look at store port. And so the other thing you can do is run process process monitor, and then you can see the I/Os being issued by any applications and determine whether there's an issue ongoing with that particular application or not, based on the time that those I/Os take to complete. And so let's look at the various ways to trace I/O on Windows here. Number one thing that I wanted to show you is first this blog post, which I will definitely link to. This shows you basically where store port fits, right? So store port is it's at the very bottom of the stack here for the operating system. It tells you how to create a store port trace, right? It tells you how to stop it. It tells you how to manually convert it, or use the XR Power Pivot table here with the readable file here, etc., etc. Not going to go into detail of that. This is just how you can do interesting things with store port, and this blog post actually explains, with nuts and bolts, how to go about using it really. And so the other thing I want to show is Procmon. So let's go ahead and kick that off, because I want to show you what happens when we issue an I/O as seen by Windows. So I'm going to kick off Procmon here within my VM. And so be mindful, this is very, very, very costly from a performance point of view. Running Procmon on a production system can have a significant impact. Okay, so be careful what you do here. I am already filtering things on the Procmon trace before I even kick it off. Okay, so I just make sure that I capture only the things I want. And in this case, I only want IOs issued by SQL Server.exe. So I click OK, and then it's filtering a bunch of stuff when nothing issued by SQL Server. So I'm going to go ahead and kick that off. I'm inserting another value into my table. And so you can see here, right, that immediately the moment I issued that IO, and look how this is actually very precise on the time of day that it was issued, right? You can see what path, what file I was issued against. You can actually see the offset, the same information that we saw in that extended event session, right? You also see the length of it, and very important is the flags. So remember what I told you before, whenever you issue a write against a transaction log, the write has to be non-cached, right through all the way. These are the right flags for a transaction log write. Okay, so this means that I am not actually keeping that IO in any volatile area of storage, and that's super, super, super important for durability. So you can see that SQL Server was doing other operations while we were discussing things. So that's kind of how it goes for Procmon. Okay, so we're going to go and look at the hypervisor now. Now I want to make a couple of comments here. Number one comment is, if you're looking at Hyper-V, some of you use Hyper-V. Hyper-V is basically Windows underneath the hood, right? So troubleshooting I/O at the storage issues within Hyper-V basically becomes an exercise in troubleshooting I/O within Windows itself. Right? It's not very difficult to connect the dots there. But when you're using another hypervisor, and I'm going to be talking about VMware here because VMware is the most widely used hypervisor in the world when it comes to SQL Server, there are obviously other things at play here. And so you need to understand what the architecture of the hypervisor is, which areas you can look at, right? What are the what's the observability of your hypervisor? Where can you tell that there's something wrong at the various layers of your hypervisor? Because hypervisors are not monolithic, right? They're not any one thing. They have queues for storage, and they have the management of the virtual devices and the management of the memory and the CPU and all these things, right? They're very complex pieces of software, and so it's important to understand which areas of the hypervisor you can actually look at. And so here what we want to focus on, really talking specifically about VMware, is how can we tell whether there's a storage problem from the VMware point of view. And so the first thing that comes to mind for me specifically is monitor your queues. Right? VMware has more than one queue, and I can claim that I always remember the names of these queues. So I refer people to this blog post that was beautifully written by my coworker, Cody Hosterman, that shows you exactly all the different queues within VMware, exactly what they mean, and how can you tell whether there's a problem or not in your storage subsystem within VMware. And so the other article that you see here, this article at the bottom here, is kind of the basis for Cody's blog post here. And so this blog post, I'm happy to show you. That is, where is this guy? This is actually right here. Okay, so this is the blog post. Using ESXtop to identify performance issues for ESX and ESXi. So this is updated rather frequently, but it explains how to use ESXtop as a utility to determine what kind of queuing is taking place within your hypervisor. And so I'm just going to leave it at that for that. Understand that hypervisors have queues for your I/O, right? And this is something that we talk a lot in that previous presentation that we discussed again at the beginning of this talk. But one of those queues actually have a computational cost, right? Every queue does. So understanding whether there is a problem with the queuing at the hypervisor level is fundamental there. And so another thing that you can do in your hypervisor, even before you start looking at your queues, is look at your performance monitors. right? So your performance counters from your hypervisor itself. And so here you want to focus on the same things that you focus on, across the stack, which are latency, IOPS, throughput. All of those numbers are available on a per virtual disk basis and also potentially on a per data store basis. So if you're using VMFS, right, it's a big container, right, where you actually create, on which inside of it you create virtual disks. You want to know what the latency is overall at the data store level, and maybe if you have particular per virtual disk counters on performance, you want to be able to tell whether there's a bigger issue overall. That big container has a problem; it's not able to serve I/O, and all the virtual disks inside of it are being affected, or whether any particular virtual disks are having issues and the other ones are not. So it's important. It's important to understand that, and so in addition to that, if things get super complex, and for whatever reason you have to crack open the SCSI packets, or you actually have to profile the SCSI communication between your hypervisor and your storage device, regardless of whether you're using a storage array or you're just using a PCIe attached storage or some hyperconverged solution or what have you, you want to make sure that you understand that there is a capability for you to profile I/O as it's leaving the hypervisor against the storage device, right? So you're basically tracing at that point, and this stack, which is right before it leaves your hypervisor box and actually hits your storage device, to understand whether there's any issues with SCSI packets traversing the network there. And for that, I wanted to point you guys to this particular blog post that shows you how to use vSCSI stats, which is a tool specifically for profiling storage on VMware ESXi. And so this isn't updated very frequently, however, still in use out there. And so I want to illustrate the concept, right? The concept here is whenever you want to profile a system and understand what's going on with that system, you need to understand what points of observability that system has. And if it means that you have to crack open things right before it leaves that system performing calls against another system, so be it, right? Sometimes you have to get down and dirty at that level and understand what's happening there. Anyway, I wanted to show you super quick VM queuing using ESXstop. This system is not very busy, but I just wanted to show you what happens when you run ESXstop here. This is I'm connected to an ESXi server in my lab. Just run ESXstop, and what you see are all the different processes running within VMware. If you had a particular VM that will be giving you grief in terms of CPU usage, etc., you will notice that here. But if you press U, the letter U in your keyboard, then ESXstop switches from the generic view into the storage-specific view, so where you can see all the queues. And so what matters here is you can see the queue lengths, right, per device. And so you notice that some devices are set to 128, and hey, this device right here is set to 32. Maybe this device is actually being impacted by the fact that the queue length is lower than that, right? So you want to make sure that you look at all these counters and understand, whether you have some issues with, reads per second, writes per second, megabytes read per second, and megabytes written per second, whether any of these are impacting your system, right? You can correlate what you're seeing at the different levels of the stack. If you're seeing high latency on the SQL Server side, and you're seeing high latency on your hypervisor as well, then you're following the right path, right? The problem is still either at that layer or further down the stack. That's kind of how it goes. All right, moving on. Troubleshooting at the storage network level. Now, remember where we're at. We looked at the application, SQL Server. We looked at the operating system. We looked at the hypervisor. Now we moved one level below the cake. Now we're looking at the storage network. So what can we do here? You can already start seeing a pattern here, right? The counters, the same counters that we were looking at. Those are critical. You always want to see what the latency is like, what the IOPS are like, what the throughput is like. It's just that when you're looking at the network doesn't really understand an IO block size, and it knows packets, right? And so what you need to do is see whether there are errors on your interfaces, whether your network links are constrained in terms of throughput. And so If you notice that your storage device seems to be doing just fine, but your host your host, if you're using bare metal or a hypervisor, or your VM tell you otherwise, maybe something going on with the network, right? This is actually something that we see a lot because, what we do is sell storage arrays. If you don't have proper connectivity between your host and your storage array, you will definitely have issues, right? That pipe between your host or your hypervisor machine into your storage device is fundamental, especially if you're using a storage array, because you're not going to be able to get the best performance out of it if you don't have enough pipe and enough lanes to send information down to that storage device. So is your connectivity good? That's the first question that you have to ask yourself. There are multiple ways of measuring connectivity. What I do just to make sure that the plumbing is good in a storage subsystem is that I run a quick disk speed. Right, disk speed I don't necessarily love as a storage validation tool. But you know what? It can tell me whether there's any issues with the connectivity itself. Because if I actually reach good numbers in terms of throughput against that storage device, whatever it is, I know that I'm actually getting, I know that I'm capable at least of reaching those numbers, or that I should be aiming for reaching those numbers, right? And if I run the speed and I see the latency super high against a given storage device, then I need to set my expectations, right? That whatever I/O I issue against that storage device is going to be slow or slower than I expected, depending on your circumstances. But the questions that you typically have to ask yourself when you're working with a storage network: are my network links up? Is everything connected at the right speed? Right? I have seen this way too many times, where customers are using iSCSI, and iSCSI instead of switching at 10 gigabits per second, it's switching at 1 gigabit per second, and that is super slow. Right, all things considered, so an order of magnitude slower. On a 1 gigabit link, I think the most you're going to be able to push is 125 megabytes per second, and that's even in the best of conditions. So you're not going to get throughput out of that link if it's set to the wrong speed. And so it's fundamental to give your host or your hypervisor host plenty of lanes to communicate versus your storage device, whether you're using a storage array or whether you're using PCIe attached storage, right? You want to make sure that your PCIe slots are the correct ones, and your storage devices are operating at the right speed within your computers, etc., etc. And if you're using a hyper-converged infrastructure, that you have great connectivity between your nodes and your hyper-converged infrastructure, because otherwise you're going to run into performance issues, right? And you're not going to be able to explain quickly what's going on. This is also why it's good for database people to understand a little bit about the infrastructure that they're running on top of, so they can clearly pinpoint problems when they see them, right? The more you get exposed to the underlying infrastructure of things, the better off you're going to be. And the same problem actually happens in the cloud. If you have a storage and you pick the wrong disk for your VM, you're not going to get that throughput that you want. You're not going to get that latency that you want, or that low latency that you want. So you want to make sure that you pick the right storage for your workload. And so, lastly, just like we were talking about observability at the different layers of a hypervisor, the same applies to a storage network. So you are sending packets from your hypervisor or your bare metal host into your storage device. If there's a network in between, you can always observe at given points on the network. And so there are some techniques like port mirroring, for example. If you have a switch in between your host and your storage device, you can mirror a port and observe the packets flowing through that port without actually affecting the workload. And so that's one of the ways that we troubleshoot things on our customer sites. When things get ugly, if the network, it's clearly a problem, we may even go down and start looking at packets going across the network if we are having some issues that requires us to dig into that level. But understand that that's a perfectly good way of doing things, right? And so one of the things that you can do in your own computers is set up two VMs. One is your iSCSI target, and your other one is your iSCSI initiator. Right? So your initiators are going to be connecting against the target, and you can actually capture iSCSI packets being sent from one machine to the other using something like Wireshark or Network Monitor from Microsoft. So that's a good way to exercise your curiosity and learn more about network troubleshooting tools. All right, so finally, troubleshooting at the storage device level. So this becomes a very much a vendor dependent question, right? There is no panacea. There's no run book that works for every vendor on how to troubleshoot the storage devices. So I'm gonna keep this conversation generic for you guys, but I'm also gonna throw probably a lot of opinion here. But again, this is highly device dependent. So the first thing you got to do when you suspect a problem with your storage device is involve your vendor, right? The performance as seen by you're gonna notice that the performance as seen by the storage device is degraded. And so this is a case where you have latency is high throughout the entire stack, your throughput may be low throughout the entire stack, and you're just not getting the performance you need, right? You're looking at your storage device, and your storage device is telling you, my latency is high as seen by the storage device, not by the higher levels also can see the latency, right? But it's a completely different scenario when your storage device is doing totally fine, but the higher levels above are not doing so well, right? You know that the issue is somewhere else. Right? So, but when you can clearly tell that your storage device is generating latency on its own, right? Remember how storage devices work, right? They give you a latency profile that goes like this, and at some point you hit the maximum capability of the system, and everything else you throw on top of that, it becomes latency, right? It's kind of like a J curve. Every single storage device has those kinds of that kind of a response curve. And what you want to understand is whether you are in this part of this hockey stick or you are in this part of the hockey stick, right? You're still within the realm of good performance for that storage device, or you've overwhelmed it. If you've overwhelmed it, everything you throw at it's just going to become latency, right? That I/O, whatever I/O you throw on top of the maximum capabilities of that storage device will just become latency. And so this is a fundamental thing for us in the storage world, right? We try to understand whether what we're looking at is a problem of the storage device itself, or is some change in the workload, provided that we size the workload appropriately for the storage device. And so, if your storage device can indicate busyness, meaning how busy am I, right? Am I able to handle more workload? That is a good indicator, right? Not every single storage device can tell you this, though. Sometimes the storage devices just tell you how busy they are by giving you a latency number, and you don't know anything else. But some other more complex storage devices would actually have something like a meter, right? It may not be necessarily the CPU meter. It may be some other meter. You have to ask your storage vendor what that is. Is there one way to tell what my storage device, or how busy my storage device is? What is that, and how can I tell whether I have a problem somewhere in my stack or I have a problem on my storage device, right? So that's important to understand. But remember what I was saying before. If your storage device is not sized for your workload, you will never get great performance out of it. That's fundamental in the storage world, right? You have to make sure that whatever storage you pick for your workload is able to handle it, and then you have enough cushion so that if your workload increases, your storage device can continue to handle that workload. And so this is some of the things that we do on our support side all the time, right? We try to make sure that our customers are getting a great experience on their storage devices, and if we notice that their storage devices are going over they're getting super busy, we can proactively reach out to them and tell them, hey, there may be something going on with your storage device. Did you change the workload, right? And workloads change naturally. We don't expect every customer to actually track, how every single change that they do to the workload and then know exactly the impact of it on the storage devices themselves. But you just have to understand that you started with a given workload that was designed for a given storage solution, and over time that workload grew and became a bigger workload. And now that storage device is not able to handle it itself. So is it time to switch into get that storage device upgraded somehow, or just switch storage devices altogether? It's super important. Another thing that may be happening, depending on the layout of your storage device, is tiering, right? Do you have a tier of SSDs or Optane drives at the top of your storage device, and then you have much slower storage devices at the bottom? That typically manifests itself when you have sustained writes or sustained workload against that storage device, right? Where you overrun the cache or the fastest tier of storage available in that particular device. So this is another thing that may be happening on a storage subsystem. But these are the questions that you have to ask yourself. Also, are you seeing the effects of garbage collection of some sort? Right, your storage subsystem may work like may work like an area of memory that has to eventually be free up some unused blocks, and much in the sense of much like a garbage collection is performed by .NET or Java, right? If you have such storage device, SSDs actually work like this, right? They do have to be you have to run garbage collection within SSDs every so often. And that doesn't mean that every single storage device that uses SSDs is going to show you some inefficiencies, or you're going to see some weird behavior when the garbage collection happens. But you don't know that unless you talk to your vendor, right? So you should ask your vendor, could I be seeing issues from our garbage collection right now? This is very common to see on PCIe attached SSDs, and this is one of the more common things to see. If you have a very heavy workload, you may potentially see latency spikes on that workload as that device performs garbage collection, and you can't quite explain what's going on. Right? Some of the newer generation of storage devices that use SSDs can clearly tell you when they're done doing garbage collection by you querying them at the lower level possible. Right? But not every single device does this. So understand that that's also a thing. All right, well, that was the presentation. Thank you so much for coming today. Remember, I have a ton of time still left to ask questions. I'm going to remain online as much as I possibly can to answer any questions you may have. Thank you so much to our sponsors, and Microsoft in particular, for supporting us. And again, there's several ways for you to win prizes at the conference. So please submit your feedback for this session. That's one way that I can learn how to become better. And it's fundamental for us speakers to pay attention to the feedback that we get from our attendees. So thanks very much for coming today.